Betelgeuse is a red giant star. If it were placed in the position of our Sun, its surface would extend all the way out to Jupiter's orbit. This enormous and highly unstable star is destined to explode. Such explosions are among the most powerful radio energy bursts in the universe, releasing more energy than 1 billion suns combined. Are you ready for what's coming? Betelgeuse, a massive red star and one of the closest stars to Earth, has recently experienced a dramatic dimming that has captured attention and stirred mixed emotions worldwide. This unusual fading has sparked speculation among astronomers and the general public about what it might mean. Some scientists think this strange behavior could signal an impending cosmic explosion, a violent event occurring when a star exhausts its nuclear fuel and collapses under its own gravity, causing a massive blast. This possibility has raised concerns not only within the scientific community, but also among the public, as it invites questions about potential effects on our planet. Betelgeuse is a prominent member of the Orion constellation, easily recognizable in the night sky by its distinctive shape and bright stars. Also known as Alpha Orionis, it is the brightest and largest star in this constellation. Recent data collected by NASA's Hubble Space Telescope, along with observations from various other observatories, revealed that Betelgeuse underwent a significant mass ejection in 2019. While coronal mass ejections are common in our Sun, this event was extraordinary for a star like Betelgeuse, attracting the curiosity of astronomers worldwide. This phenomenon adds a new perspective on how we understand the life cycles and dynamics of massive stars. The exact distance to Betelgeuse is still debated. Some estimates place it farther away, while others suggest it could be as close as 724 light-years from Earth. Measuring the distance to red giants like Betelgeuse is challenging due to their immense distance and unique characteristics. Betelgeuse shines approximately 1,000 times brighter than the Sun, making it one of the most luminous stars visible in our night sky. However, this incredible brightness comes at a cost. Betelgeuse burns through its nuclear fuel rapidly, accelerating the end of its stellar life. Eventually, the star will run out of fuel, collapse under its own gravity, and likely explode in a cosmic event that could create either a neutron star or a black hole. This leads to an important question. Does Betelgeuse pose a threat to Earth? If a supernova were to occur just a few light years from us, the consequences could be devastating. Such an explosion can emit an enormous amount of light, potentially rivaling that of an entire galaxy. Even though Betelgeuse is relatively distant, comparable to stars like Alpha Centauri, the impact of an explosion could still be widespread. Interestingly, since the last supernova observed in our galaxy in 1604, humanity hasn't witnessed such an event close by. The last notable cosmic explosion occurred in 1987 in the Large Magellanic Cloud, about 169,000 light-years away. While significant, it posed no immediate threat to Earth, but serves as a reminder of the scale and impact of these galactic phenomena. The concept of a danger zone around a typical supernova is intriguing and could have serious consequences for life on Earth if such an explosion happened nearby. However, in the grand scheme of cosmic events, supernovae are relatively modest compared to gamma-ray bursts, which are far more powerful and pose a different level of risk. Supernovae can cause widespread damage by bombarding planets with intense radiation and can even destroy a planet's ozone layer, leaving it vulnerable to harmful ultraviolet rays. Long after a cosmic explosion has occurred, objects can remain vulnerable to the relentless radiation emitted across the universe. A recent study highlighted new potential hazards linked to massive stars that end their lives in spectacular explosions. When these giant stars explode, they can produce some of the brightest flashes ever observed in the cosmos. In fact, a single such explosion can outshine the combined light of billions of stars. This raises intriguing questions about the consequences if a star like Betelgeuse were to explode. Should this happen, Betelgeuse would become the second brightest object in our sky after the Sun remarkably. Despite its great distance, it would shine brighter than a full moon and be visible even during the day. The sheer intensity of the blast would cast shadows in the dark, creating an awe-inspiring yet terrifying spectacle that demonstrates the immense power of such cosmic events. While the visible light from a supernova is astonishingly bright, it represents only a fraction of the total energy released. Although the intense light itself could cause temporary blindness, The more serious threat comes from the high-energy radiation emitted alongside it, such as X-rays and gamma rays, which can have far-reaching effects. One of the gravest dangers is that this radiation can accelerate the destruction of Earth's protective ozone layer. Without this shield, life on Earth would be exposed to harmful ultraviolet solar radiation, potentially leading to widespread extinctions. After the initial explosion, additional hazards develop over time. In the immediate aftermath, intense radiation poses acute risks. Later, high-speed subatomic particles called cosmic rays, propelled close to the speed of light, begin to infiltrate the solar system. These cosmic rays can further degrade the ozone layer and saturate Earth with harmful radiation, amplifying the dangers from the original blast. Moreover, cosmic rays carry a significant portion of the explosion's total energy and can affect the planet for centuries. There is evidence that Earth has been impacted by such cosmic events before. For instance, elevated levels of iron-60, a radioactive isotope produced in supernovae, have been discovered in ocean sediments and lunar soil, suggesting Earth encountered supernova ejecta within the past few million years. Currently, astronomers have identified no nearby stars likely to explode imminently in a way that threatens life on Earth, based on what we know about gamma and cosmic ray risks. However, new research has uncovered additional dangers linked to specific types of supernovae. Some of these explosions can emit highly energetic X-ray radiation over long distances, posing greater threats to planets. This occurs when a dying star is surrounded by a dense shell of material. The explosion shock wave heats the shell to extreme temperatures, producing intense X-rays capable of traveling vast distances through space. The brightest X-ray supernovae could deplete up to half of a planet's ozone layer, potentially triggering extinction events for planets within about 150 light-years. Fortunately, no such X-ray supernova candidates have been found near Earth to date. Still, these findings have refined our understanding of the cosmic habitable zone, the region within galaxies where conditions might support life. It appears the zone may be more limited than previously thought, as the outer areas of galaxies lack sufficient star formation to produce essential elements for life. The formation of rocky planets takes place in certain parts of the galaxy, but the inner regions, where stars are born and die more rapidly, pose unique dangers. Frequent cosmic explosions in these zones illuminate the surrounding space, raising risks for any potential life there. Recent studies suggest that the inner edge of the galactic habitable zone is likely farther from the center than previously believed, altering our perspective on where life might thrive. So, what will Betelgeuse's cosmic explosion look like from Earth? Although Earth's biosphere will likely remain unharmed, the spectacle itself will be hard to miss. Scientists predict that after the blast, Betelgeuse will shine brightly for over 90 days, glowing at about half the brightness of the moon, several times dimmer than a full moon. It will appear as a bright point in the sky, visible even during daylight hours, casting shadows at night and captivating all who look up. This celestial event will undoubtedly attract global interest. The explosion will be visible to the naked eye for months, gradually fading as its remnants disperse. Researchers are studying Betelgeuse to better understand the life cycles of massive stars and the processes behind their dramatic deaths. This knowledge is crucial for grasping how the universe evolves and how elements form during such cosmic blasts. The light and energy released create a wide range of heavy elements, like gold, silver, and uranium, through a process called nucleosynthesis. This enriches the interstellar medium with the building blocks of life, which can later become part of new planetary systems. This ongoing cosmic cycle of destruction and creation highlights the interconnectedness of the universe. Though Betelgeuse's supernova will occur many light years away, it reminds us of the immense forces shaping the cosmos. Its explosive death will contribute to the birth of new stars, planets, and possibly life elsewhere. The star's final blast will release massive amounts of energy and elements, such as carbon, oxygen, and nitrogen into space, seeding future stellar and planetary formation and influencing galactic chemistry for millions of years. The explosion's remnants will form a supernova nebula, spreading gas and dust outward and enriching nearby space. The shock wave will compress dense gas clouds, triggering the birth of new stars, continuing the cycle of stellar evolution of death and rebirth, in which Betelgeuse's final act plays a part. Material from Betelgeuse's explosion may eventually coalesce into new star systems and planets. Over billions of years, some of these elements might help form planets capable of supporting life, just as our solar system's elements originated from ancient stellar explosions. This cosmic recycling keeps the universe dynamic, with stars constantly evolving and reshaping their environments. While we may not witness Betelgeuse's last moments ourselves, future generations or civilizations, on Earth or elsewhere, will study and learn from this extraordinary event. Its impact will likely inspire advancements in astronomy, deepening our understanding of stellar life cycles, element formation, and the potential for life beyond Earth. Betelgeuse's supernova will also remind us of life's impermanence. Despite its immense size and brilliance, even such a star must eventually perish. This humbling truth encourages us to cherish our time and existence on Earth while reflecting on the vast cosmic forces that govern the universe, forces that shape it in ways we are only beginning to understand. Ultimately, Betelgeuse's explosion marks the end of one cosmic chapter and the start of another. As the universe continues its endless transformation, this event will be etched into the fabric of time, a testament to the powerful cycle of creation and destruction that defines the cosmos. Though the explosion poses no significant threat to Earth, it will surely inspire wonder and deepen our understanding of the universe and our place within it.